Hi everyone, and the objective of this video is to continue with questions related to the entropy and the second law of thermodynamics. So here is our question. Steam at 270 degrees Celsius and 800 kilopascals enters an insulated open feed water heater with a steady mass flow rate of 1.5 kilograms per second. A separated stream of liquid water at 50 degrees Celsius and 800 kilopascals enters with a mass flow rate of 4.5 kilograms per second, and a single mixed stream exits at 800 kilopascals with an unknown temperature. So the question is asking us to ignore any changes in kinetic and potential energies, and to calculate A, the temperature at the exit, B, the rate of entropy generated, and finally to draw a fully labeled TS diagram that maps the entrances and the exit. So to look at our diagram of our open feed water heater, we have our first entrance over here, state 1. And at state 1 we have a temperature at state 1 is equal to 270 degrees Celsius from the question. The pressure is 8 bar, since it's 800 kilopascals, and our mass flow rate